Alright, so good morning. This is lesson for day 73, graphing quadratic functions. Today, or this lesson is you doing math. We know that we can graph anything using a graphing calculator, and I want you to know that that's okay for you to do that as a tool, and you should always check your work, okay? But one of the things is that you need to know how to graph by hand when you don't have a graphing calculator, okay? So just know you can use Desmos, you can use your calculator, but today if you don't put the effort in and you don't know how to graph it, then you're going to struggle, okay? When we do a test or, in the future. And it helps us conceptually figure it out. So one of the things I want to show you is, like, let's say I go to Desmos, okay, and let's say I show you this graph right here. Eyes up on my screen, please. You see how this is the standard form? I can move around B, C, right, and A, right? What does A do to my graph? It opens it up or down, makes it more narrow or wider, right? So does the shape of my graph change at all if I just move B or C? Does the way it looks change? No. The vertex changes. You see this purple point right here? You see how this is changing? But does the shape of my graph change? No. Okay, cool. So I wanted you to see that because as long as A is the same, we know that all the points around the vertex will be the same. So for example, this could be a point here. Like I'm going to set some points up here, like -1. 1 is a point. I wonder if we could do that. B plus 1, C plus 1. Hey, that works. Oh, that's so awesome. I totally do that. B minus 1, and C minus 1, C plus 1. You see how this point right here is the same right here and here? Do y'all see that? So watch me move my C again. You see how they all move together? That point will always be there. Or let me do a couple more points. B plus 4 and C plus 4. Oh, that's not right. It's B plus 2. I'm sorry. B plus 2 and C plus 4. And one more. I'm going to put B minus 2 and C plus 4. Okay? I'm going to undo all these. Do you see how I can move the vertex wherever, and all of these points will always be in the same place in relation to the vertex?
Yeah.
Do y'all see that? Does that make sense? So it's kind of like a football team. You know how like a football team has a play, and you have like, it all depends where the ball is, right? The ball is like the vertex, and then all the players line up around the ball. Does that make sense? Does it matter where the ball is? Do the players line up differently depending where the ball is, or do they line up the same way on the same play? What's that? They line up the same. Does it matter if they're on the 30-yard line or on the 50-yard line? Do they line up the same? Yeah. So that's the idea here. Or another way, are there any dancers in here, like dance team or dance students? Okay. So like I bring that up because my wife's a dance teacher, right? Let's say you have the lead role in a dance and you're in the front, or a cheer team, right? You're in the front. Let's say if you're on dance or cheer and this is you, you'll always know that if you turn to the back left or back right, you're going to have a person right here and one right here, right? Does it matter what stage you perform on? Will it be a different formation? No, it doesn't matter, okay? I want to show you, that's the big idea, that's the concept I want you to get, okay? So I'm going to go back to the lesson here. The steps are up on the board. If you're in the video, please pause right here and write these down. So these are the steps. Here we go. Numbers 1 and 2. Graph y equals x squared plus 4x plus 1. Okay, eyes up on the screen. So the first thing I want to do when I graph is I want my final answer to look like y equals a times x minus b squared plus c. Because I know that if I have these, then I could graph this. My original problem doesn't look like that. So I need to make it look like this. So what I'm going to do is I'm going to start using a method by completing the square. So I'm going to rewrite this so it kind of helps me to see it like complete the square. I'm just going to move the equal sign and the y to the other side. And instead of y, I'm just going to change to the 0 for a little bit, okay? Which is going to be totally fine. Now I'm going to pretend like I'm completing a square. Doesn't this look like a complete the square problem now? Okay, so I'm going to just subtract 1 like I did a couple of days ago. So we got x squared plus 4x is equal to -1. Okay, now I'm going to complete the square here. What goes inside this area here? I'm going to do a side problem. We got c is equal to our b, which is positive 4, divided by 2 squared. All right, I took 4, put it inside here. What's 4 divided by 2, everyone? 2 squared is 4. Good. So I'm going to add a 4 here. And I'm going to add a 4 underneath here. So this is just like a couple days ago. We got x. This is a perfect square trinomial, so this is x plus 2 squared, which is equal to 3. Okay? Right? Doesn't this kind of look like my vertex form now? Does this look familiar? So here's where you need to pause. Do not complete the square here. We're going to move this 3 back over to the other side. So we're not going to take a square root because we're not solving. We're going to graph. So this is different now. So now we're going to, I'll move this over here so you can see it. We got x plus 2 squared minus 3 is equal to 0. And remember when I changed the y to a 0? Let's just change it back now. Let's just put a y here now. And we're going to rewrite this so it starts with y. Y equals x plus 2 squared minus 3. Is this in the standard form of the equation? Or the vertex form, I mean? Does this look like the vertex form? Yeah, it does. What's a on this problem, everyone? What's a equal to? 1, right? What's b? Nope. It's -2, right? Isn't this supposed to say x minus something? So it's supposed to be x minus and -2. You all see that? Does that make sense? Okay. Yes? Yeah, that's right. Yeah, it would be the opposite. Good question. Okay, so b is -2 and c is -3. Okay, so now I have enough information. I'm going to start graphing this. I know that a is 1, so is it going to open up or down? Up, because it's what? Positive. Good. Okay, so we're combining these concepts now. We're going to go from our origin, we're going to go to 2, -3 to plot our vertex. Okay? There's my vertex. I know it's going to open up somehow. I'm not going to just do it sloppy, though. Okay? Remember what I said earlier about our vertex? There's points that are around it. Okay? Kind of like a football team or a dance team or a cheer team. Okay? So, here's a trick that I'm going to teach you that's going to help you find all of the points. Okay? Eyes up here. We're going to do this T-chart on the bottom left. Please watch up here. No writing right now. We're going to put a is equal to whatever it is up here. A is equal to 1. And then I'm going to put left, right, 1 and left, right, 2. And that tells me how far up am I going to go up from the vertex. Okay, so this looks confusing. This is all new to you. So this you always set up like this. And this is how we do it. The first one, left, right, 1. I'll use a different color. Okay, left, right, 1. So we square the 1. What's 1 squared, everyone? 1 times 1 is 1, so we're going to put a 1 here. Okay, I squared this left, right, 1, and then I multiplied it by a, and we got 1. So what does that mean? Eyes on the screen on the graph now. That means if I go left or right 1 from the vertex, I'm going to go up 1. I know that I should have a point here and here. Does that make sense? Okay, so I'm going to put those points down. Right, just like on a dance team or a football team, I know that I'm going to have another person in that relation, right? Okay, then back here at number 2, or on the second one, what's 2 squared? I'm going to go back to here. What's 2 squared, everyone? 4 times our a. What's 4 times 1? 4, good. So I'm going to use green here to represent this point. Let's all go back to the vertex. back to our vertex. It means if I go left or right 2, I'm going to go up 1, 2, 3, oh, and, sorry, not oh, 1, 2, 3, 4. So I should have a point all the way up here. I'm going to go left 2, and then up 1, 2, 3, 4. There should be a point here. Do y'all see that? Now it looks like I skipped boxes, right? Because each box here represents a half unit. Okay? Now I'm going to graph. And then I'm done. Put some arrows at the end because I know that on my paper it's limited, but if I were on Desmos or Graphing Calculator, that graph is going to go up forever. Okay? Now what should we do even before we're done? We should check our work on Desmos, right? So you shouldn't get any of the problems wrong. You could just plug in the original problem into the equation and you'll see your graph that looks like that. Okay? Questions on number 1. Here we go, number 2. I'm going to go a little more quickly, and there's going to be something a little bit more tricky on this one, but I want to make sure you see it. Number 2. Number 2, I'm going to move that y over to the other side, so it's going to be equal to y on the right, so it looks familiar to us. Instead of y, I'm going to put in 0, and then I'm going to subtract 14 on both sides. So we got 2x squared plus 12x is equal to negative 14. Okay? And then what would we normally do? We see a 2 here, right? So we divide both sides by 2, right? That's if we solve. Are we solving here? No, we're graphing. So instead of dividing by 2, eyes up here really quick. On the left, we're going to factor out whatever a is here. So it says 2 in front of this x squared, so let's factor out a 2. 2 times what is x squared?
X squared.
X squared, good. 2 times what is 12x?
6x.
Positive 6x. And then I'm going to leave a little space to complete the square, in parentheses, minus 14. Okay? So we just broke this apart a little bit on the left. Now I could complete the square. I'm going to do a side problem here. I'm going to take this positive 6, focusing on that, and do a side problem here on the side. C is equal to positive 6 divided by 2, all squared. I know that 6 divided by 2 is 3. 3 squared is 9. Okay? Eyes up here, another technical thing. I'm adding 9 here. Okay, usually we would add 9 on the opposite side here, but I didn't really add 9 on the left. I actually added 9 times 2. What's 9 times 2? 18. So I'm not going to put a 9 over here. This would be wrong. We're going to put actually plus 18, right? Because I didn't just add 9. I actually added 9 times 2. You see that? Now we're going to bring the rest of the problem down. So we know I had this factor of 2. This whole thing right here is a perfect square trinomial. Here, I'll use this green. It's going to be x plus 3, all squared, which is equal to, what's negative 14 plus 18? 4. Okay. And then we're almost done. We're just going to put this into standard form. It's going to be 2. I'm going to subtract 4 on both sides. So we got 2 times x plus 3 squared minus 4 is equal to 0. Remember, but we started with a 0, so we should change this to a y. We're just going to rewrite this. Y is equal to 2 times x plus 3 squared minus 4. Okay? Yes?
Yeah, it says that x plus 3, you take half of 6 or half?
Half of 6, Yeah, good question. Half of 6. Yes? Because I subtracted 4 on both sides. I need to move this constant term here to the left. You see that? Okay, now we all know A, B, and C. What's A on this problem, everyone?
2.
Good. What's B? B is negative 3. Good. C is? Good. Okay, cool. So now we could plot our vertex. Our vertex is negative 3, negative 4. So we go to negative 3, down negative 4, so we know we're going to focus on this point right here. Is it going to open up or down, everyone? Up, right? Because we know it's positive. Okay, so now we have to do a t-chart. Is this graph going to look the same as on graph 1? Nope. Why not? Because A's are different, right? Is our A different? Yeah, so it's going to look different. So it's a different formation. It's like a different play or a different performance, right? So we're going to do a t-chart here for 2. A equals 2. We're going to do left, right, 1 from the vertex and left, right, 2. Okay? Here we go. Left, right, 1. Let's all square. What's 1 squared, everyone? 1. What's 1 times our A this time? 2. So we're going to put 2. So starting at our vertex, we're going to go left 1 and then go up 2. So we should have put a point here, right? From the vertex, we go right 1 and then up 2. Put a point here. Does that make sense? Back to the vertex. Let's focus on the next one. 2 squared. So here we go. Left, right, 2. What's 2 squared? 4. 4 times our A is 8, right? So now we're going to go right 8 here. Back to our vertex. We're going to left 2. Up 1, 2, 3, 4, 5, 6, 7, 8. Put a point all the way here. And then right 2, 1, 2. Up 8, 1, 2, 3, 4, 5, 6, 7, 8. Plot a point all the way up here. Okay, I ran out of graph paper. Do you think I could do left, right, 3 if I needed to? Yeah, we could have. What's left, right, 3? 3 squared is? 9 times 2? 18. We're going to put points all the way up there. But we're not going to do that on this problem because we ran out of graph paper. So, of course, we're going to just draw our U. It's not going to be a V. It needs to look like a U. Plot a graph, and we're done. Okay? It took a while, right? Okay. So, today is you doing the graphing. It's not you doing Desmos and getting the answer and just picking A, B, C, or D on your AMs. It's like you have to know how to graph. Once we practice this enough, it'll be easy, I promise you. Okay? So, I want to hear some talking today. You all look sleepy, so let's start with the 4s. 4s will start today. 4s will talk to the rest of the group about number 1, teaching them. And then when they're done, let's go back to 1s. 1s will talk to the rest of the group about number 2. Ready, set, go. Okay, number 3. Let's all write this down. Number 3. Let's spend about 10 seconds writing the original problem down. Okay, so on number 3, I'm going to walk you through this. So let's do this one together. The first thing I want to do is I want to make it look like I'm completing the square. So you don't always have to move y over, but let's just do it so it's more comfortable for everyone. I'm just going to put equals to y. And then what should I also do with y? Change the 0. Okay, we're all working on this, yes? Okay, just want to make sure people are all participating on it. Okay. Good, so let's start pretending like we're completing the square. What should I do to start completing the square? Add 1. So we're all doing this together, adding 1. So we got x squared plus 2x. Leave a little space is equal to 0 plus 1. Okay, we got got a blank space here that I want to fill here. So to complete the square, what do I need to add in this blank space to complete the square, everyone? What's that? 1, good, because we're going to take half of 2, which is 1. 1 squared is 1, so we're going to add a 1 here. We're adding a 1 pound here on the left side and 1 number on the right side. Now it's balanced. Okay. Okay, left side is a perfect square trinomial. What does this turn into, everyone? X plus 1 squared. Good. Which is equal to? What's 1 plus 1? 2. Good. Okay, now we're going to subtract 2 on both sides. We would normally square root here, but what do the directions say? Does it say solve or graph? Graph. Good. So we're going to subtract 2. So we're going to say x plus 1 squared minus 2 is equal to 0. And then instead of 0, what should I return it back to? Y. So you could leave it like that, or if it's more comfortable, you could put y equals x plus 1. This whole quantity squared minus 2. Okay? And there you go. It's now in vertex form. Let's identify A, B, and C. What's A?
1.
Good. B?
Negative 1.
Good. B is negative 1. C?
Negative 2.
Excellent. Okay. Now we're going to Doceri. Or not, to Doceri. Not Desmos, but to Doceri. We're starting to graph this, so we got our vertex is negative 1, negative 2. So we're going to go to negative 1, down negative 2. We're going to plot our vertex. By the way, I got a question for you. Is this open up or down? Opens up, right? How do we know it opens up? It's positive, right? So we got to make a t-table. What's a equal to here?
1.
Okay, let's all do this on our papers too. We're going to do left, right, 1, left, right, 2. And I'll do left, right, 3 also. That way you can see. We could do this forever. We could do left, right, 100 if we wanted to. Okay, so what's 1 squared, everyone? What's 1 squared? 1 times our a is? 1. Good. So we're going to put a 1 here. That means if I go, starting on my vertex, if I go left 1, I'm going to go up 1. And if I go right 1, I'm going to go up 1. Okay. Next one. Left, right, 2. What's 2 squared? 4. Good. 4 times our a is? 4. Good. So we're going to go back to the vertex. If I go left 2, I'm going to go up 1, 2, 3, 4. Plot a point here. Back to the vertex. Going right from my vertex. 1, 2, up 1, 2, 3, 4. Right up here. Okay? Can't do anything else, so I'm going to just plot my graph like so. And then I'm done. Right? What should I do to check my work? Desmos. Can someone check Desmos for me just to make sure I did it correctly? What do you notice about number 2 now? What do you notice about number 2? Good. So this is kind of confusing, right? Are we supposed to do, are we supposed to complete the square here? What do y'all think?
Yeah.
How do we get this problem to look like this? Turn your group for like 15 seconds and maybe predict. How do you make this look like this? There's no right or wrong answer. Okay, ready? Let me show you how to do this. I heard some good conversation. Ready? So, would you agree that this is the same thing as y equals to 2 times x squared? Would you all agree with that?
Yeah.
And is there a, would you all agree that this is also equal to y equals to 2 times x minus 0 squared?
Yeah.
If I subtract 0, will it change my problem? No. And if I didn't see a c here, couldn't I just put plus 0? Does it change my problem? No. I don't want to add 1 or 2 because all of a sudden now we're changing the problem. It's not balanced anymore. So, is that now in vertex form?
Yeah.
Yeah, what is a equal to?
2.
Good. B?
0.
C?
0.
Awesome. So, that was an easy problem, right? Can we graph this now? Okay, let's go to 0, 0. We're graphing this. Opens up or down? I heard 2 answers, up or down. Why do you know it's up?
Because A is positive.
Oh, A is positive. Okay, good. Okay, so now we're going to make a T-chart. So A is equal to 2, left, right, 1, left, right, 2. Let's do left, right, 3 for fun. Okay, left, right, 1. 1 squared is? 1. 1 times 2 is? Good. Left, right, 2. 2 squared is?
2 or 4.
4 squared is, or I'm sorry, 4 times 2 is? Good. 3 squared is? 9 times 2? 18. Good. Now, I don't have enough room for 18, but I could do the other one. So, left, right, 1. I'm going to start left from my vertex down here. I'm going to go left 1, up 2, right? I'm going to go right 1 and up 2 here. There should be points here, right? That's the formation of a of 2. Okay, left, right, 2. I'm going to go left 2 and then up. How many? 8 on each direction. We don't have enough graph paper to go up to 18, so we're just going to... That didn't look very pretty. Let me try that again. And that's it. Does this make sense?
Can you show us how you got 18?
Sure.
3 squared times
What's 3 squared?
9.
9 times our A.
18.
18. Make sense? Okay. Very good. Now, I got a question for you. Well, I have one question, and I want you to think right now. What do you notice between, I want you to focus here on the T-chart on number 3 and on number 1. Just on the T-chart, okay? Everyone's focusing on the T-chart on number 3 and on number 1. What do you notice about both of them? This is number 3. This is number 1. What do you notice about both of them?
They're one.
Why are they the same?
Because A is the same.
Good. So when A is the same, shouldn't it have the same formation, right? Remember what I said earlier? Does it matter where the ball is on the field if we're doing the same play with the football team? Yes. Does it matter?
No.
What about the cheer team? Does it matter where you perform? Shouldn't you have the same formation? Yeah.
Depends.
Let's just pretend there's plenty of room. Okay, look at number 4 and 2. What do you notice about the T-chart on number 4 and 2? 4 and 2. This is number 2 and number 4.
A is equal to 2 equal. It's the same.
It's the same. Dang, right? So do we have to make T-charts all the time? No, you could memorize them and then you could just know where to plot the points. Okay? Does that make sense? Hey, now look at the graph on numbers 1 and... Look at numbers 1 and 3. Look at the graphs. This is number 3 and number 1. What do you notice about both of the graphs?
The vertex is different.
The vertex is different. What else do you notice?
The same.
It's the same what?
Points.
Not slope. This is not a line. The same
Points.
relative points, right?
Yeah.
Isn't this the same shape?
Yeah.
Just a different vertex? Look at numbers 2 and 4. Look at numbers 2 and 4. Last question. 2 and 4. What do you notice? This is 2. Look at the graph of 2. And look at the 4. The same what? Good. Same shape, but different points, right? Does that make sense? Okay, cool. All the points are relative to the vertex. All right? You want to do one more?
Yeah.
Okay. Let's see, you do this last one, number 5. This one's like number 2. Okay, number 5. I'm going to erase number 6. Number 6, first period got to, but number 6 is this one. You want to do number 6?
Yeah, let's do 5.
Okay.
I'm feeling 5.
Okay, number 5. Number 5. This is like number 2. Let's see if you could do it, and then I'll start catching up with you. I'll give you a couple minutes here. Or on Desmos. Now,
Let's say
I want you to be honest with yourself. Did you really check it, okay? So, you do have to check your answers. Okay, what is our vertex, everyone? 1, 1. Okay. Do I have to make a table? Should I make a T-chart? Do I have a T-chart from another problem? Which one can I use? 2 or 4, right? So I'm just going to do this. I'm going to go quickly because we're done here. Right? That's it. We're done.
Don't you have to divide the 4x by 2 times it? So it's like...
Oh, yeah, you're right. Did I do it right?
No.
Oh, I didn't check my work.
So I have to write this.
Man, I made a mistake again. But I'm the teacher.
So everybody makes mistakes. Yeah. So
Am I right?
No, you're not.
Why am I not right?
Because you didn't do the...
Everyone, in your groups, why am I not right? There's a mistake up here. What's wrong?
If you look here, 4 4x, if 4 divided by 2 is going to be 2. 2 times 2 squared is going to be 4. Y'all thought I was wrong for a second over here.
I didn't.
I didn't even check Desmos. I just felt I was right because it looked good.
But you just said that you checked Desmos.
Of course I did.
Okay, so let's all check Desmos. Also, everyone go to Desmos, put the original problem in y equals 2x squared plus 4x plus 3.
Ashley went, I'm right. I feel so accomplished today.
Okay, so am I right on Desmos? Oh man, I screwed up, right? So should I just give up and like, I'm done, I picked the wrong answer, I'm done? Should I just give up? No, don't give up. You need to redo it. Now, where did I make a mistake? Right here on the blue line.
Yep, right on the blue line.
So I'm going to clean this up a little bit. That's too much. Okay, I'm going to clean this up just a smidget. Okay. Okay. So it's supposed to be what? Equals -3. So half of 2 is? Wait, did I do it correctly?
Yes, you did.
Yeah. What's the right answer?
What's the right answer? Well, I just lost it because I deleted it. Okay, I think some of us are confused right here. What's half of 2?
1.
Okay, what's 1 squared?
1.
Okay, we're going to add a 1 here, yes? I thought you guys checked Desmos. Are you guys just lying to me? You're confusing me now.
I did not know. You are.
What's 1 times 2?
My answer's not right.
2, good. So I have to add a 2 here. Did I do it right the first time?
No, I see right. I actually did see the mistake I made. See, I forgot when I took out 2, I only took out the 2 from the 2x squared. I didn't take out 4x.
So what is the final answer? It's y equals, and now watch this. Once you get good at this, check this out. You could jump from this step to 2 times x plus 1 squared. We know this is going to be -1, so we're going to add 1. There's your answer. Okay, so I did do it correctly the first time. Now, I tried to confuse you, right? It's important that we check mistakes. You need to be able to justify it. You need to be able to say that to your own work, because sometimes we're like, oh, we did it and we're done, and you don't check Desmos. Part of it, are you being proactive at your work, or are you just kind of like, whatever, I got it, I tried.
Yeah.
Trying is good enough. I should get a gold star for trying. Is that how it works? No, you need to you get a gold star and a good grade for checking your work, okay? Alright, anyways, that concludes the lesson. It's a long one today.